Okay, so we're going to look at law of sines today. So law of sines is a way to find the missing sides and the missing angles of a triangle. So here we have a triangle. Angle A is 90. The side opposite A is 5. And the side opposite B is 3. So I can actually find C by doing Pythagorean theorem. And then cosine of C, so that's this angle right here, is 3 over 5 adjacent over hypotenuse. And so then I can do cosine -1, inverse cosine, and I can figure out that C is 53.13 degrees. And then subtracting it from 180 minus this, minus the 90, gives me 36.87 for B. So we're going to talk about ambiguous cases in a minute, and I'll explain that extra note that we have there. Here's another example. So using something called law of sines. So law of sines is a formula. A is your side, angle A is your angle. So you can set up these proportions. So in this case, I've got angle A is 42, angle B is 63. I can find angle C by subtracting from 180, and I get 75. So I can set up proportions. Side C is 18. Angle C is 75. Side A, I don't know, and angle A is 42. So if I cross multiply now, I get 18 times 0.669. That's what sine of 42 is. And this should be sine 75 times A. And then if I divide both sides by sine of 75, I would get that side A is 12.47. So that's saying this side is like 12.47 inches or centimeters or something like that. And then I can repeat myself, set up my proportion with 18 and 75 again, and side B and 63 degrees, and if I cross multiply, I can get side B is 16.6 inches or centimeters. And what I've done here is I've solved for the triangle. I've got side A, side B, side C, angle A, angle B, and angle C. So this next part talks about ambiguous cases, and that's when there are cases where there are no triangles, or there could be multiple triangles. So for example here, what if A was too short and would not fit all the way to the other side? Then that means that there could be a possibility of not having a triangle. Then there's the case where there's one triangle, right? So the other cases have to do with the hypotenuse, or the height. So what we're looking at here is that A is too short again. In this case, A is the same length as the height, so it's a right triangle. And in this case, A is possibly, I could have an obtuse angle here and A would make a triangle. Or I could shift or swing A out and I would have a different triangle. So these are what we call ambiguous cases. It's cases where there's more than one triangle, or no triangle at all, or one possible triangle. And we're going to talk about an easy way to solve that type of problem. So here we have an example. So angle B is 32 degrees, side A is 42, and side B is 30. So angle B is 32 degrees, side A is 42, and side B is 30. And you'll notice that this is an angle, side, side problem. Angle, side, side. Remember in geometry, that was the bad one. Those are always potentially ambiguous problems. So I start setting it up. I match up the 30 with the side, with the 32 the angle, the 42 is the side, the angle A, and I cross multiply, and I get angle A is 48 degrees. So if I put that into this triangle, I have angle A is 42, angle B is 32, and I could find angle C, subtract it from 180, and find angle C. And I can solve now. So I can do angle C over side C. Here's my side C. And then I can do angle A over side A, and I can cross multiply and I can get angle C. So I have I can get side C. So here I have side C, angle A, angle B, angle C, oops, sorry, we got angle C we got from subtracting from 180, side A, side B, and side C. But what if I took that 148 and I subtracted 180 from it? Then I'd get 132. So could I still make a triangle? So the 32 doesn't change, but what if this was 132? If I subtract that from 180, I can get a third angle, which means there are actually two solutions to this problem. So now I have to also solve for side C using the 16 degrees, and I get a different value for side C. So angle A is 132, angle B is 32, angle C is 16, side A is 42, side B is 30, and side C is 15.57. So I ended up with two solutions to this problem. Now if I go back to the first problem that I did, if I try and take the 53 and subtract it from 180, I get 127. So the 90 is already here, so 127 plus 90, that's 217. I'm already over the 180, so there's no second solution. So you can always test this and see if it works. On this problem, I've already been given two angles. I can't change that. So the angle C is set. There's no other option for angle C. So you can always look and see if there's an ambiguous case, but it's not always going to work. Alright, so here's our second problem. So this time I've got angle A, I've got side A, and I've got side C. I put it into my formula and I cross multiply, and I get sine C is 1.18. I'm sorry, 1.11. If I try and do the inverse of that, I get an error message because this number is not between -1 and 1. So therefore, there's no solution to the problem. So this is a triangle that would look something like this, where you have the triangle and this side is not long enough to touch the other side. So it would be no solution. So we'll talk some more about that application in class.